In this lesson video, we're going to be focusing in on section 4.2, standard form of a quadratic equation. Our objective is to graph quadratic functions in standard form. So hopefully you remember from section 4.1 that we worked with quadratics in vertex form. Today, in our lesson 4.2, we're going to be focusing in on standard form, quadratics in standard form. And let me remind you of that equation. It is f of x equals ax squared plus bx plus c, where a cannot equal 0. Remember, if a equals 0, then that cancels out the x squared term and it just changes into a linear function, which is quite different than quadratic functions. The values of a, b, and c provide key information about the graph. We will be learning about those key pieces of information later. And the benefit of standard form is that it's easier to enter into a graphing calculator than vertex form. In example 1, we're going to talk about the features of a quadratic function when given the equation, and we're going to be using our graphing calculator to help us to do this. So it says, what are the vertex, axis of symmetry, the maximum or minimum value, and the range of the equation y equals 2x squared plus 8x minus 2. And remember, f of x and y stand for the same thing. So in this case, we're using y. So let's take a moment to type our equation into our calculator. So turn it on and go to y equals, and if you still have previous inequalities or equations in here, you want to clear them. And then also make sure you have equal signs. Okay, so now we're going to type in our quadratic. So 2x squared plus 8x minus 2. So when I press the trace button, I'm getting this graph, and if your window is not showing you the entire curve, you want to go to Zoom and then go down to Zoom Standard and press Enter, and that should give you a nice window. And from the graph, we can tell what the vertex is. We can also tell if it's a max or min, as well as the range of this curve. So as you can see, the parabola is opening up, and that confirms what we talked about in the last video. When the a value is greater than 0, the parabola is opening up. And our vertex is a minimum because you can see right here that that's the lowest point. And remember, the vertex is where the parabola changes direction. So now you may be wondering, how do we get the exact coordinate of this vertex or minimum? What you want to do is go to Second Calc. And we've been here before when we were intersecting a pair of linear equations. And now you want to go down to minimum. And it's going to ask you for the left bound and the right bound. Left bound just means choose one point on the left side of the vertex, so press Enter. And then now go to the right side, any point on the right side, press Enter. And then press Enter once more. And it'll give you the coordinate of the vertex. So the vertex is at the coordinate point -2, -10, and we're rounding to -2 since it's super close to that. One more thing we can tell from this current graph is that the axis of symmetry is at the equation x equals -2. Remember, the axis of symmetry is always the x coordinate of the vertex. And that is the point where, actually the axis where you can fold the parabola over and get the same image on the other side. The range of this function is all real numbers such that y is greater than or equal to -10. I'm getting this -10 from the y coordinate of the vertex because you can see on this graph here that all of the y values are -10 or bigger. So there are no numbers below that y equals -10 mark. So that's why our range is y is greater than or equal to -10. We can also find out these properties from looking at a table. So now I'm going to show you that quick process now. So to go to the table, you want to go to Second Table, and we've been here before for previous problems. And you want to scroll down so that you see the y values, and do you see how they're starting to repeat? Here is the vertex coordinate -2, -10 that we talked about earlier, and then you can see on either side that the y values are repeating. So that would be a good indication that this is a parabola. So like I said, the vertex is at the coordinate -2, -10, and that's the axis of symmetry, x equals -2. You can see that on either side of that axis of symmetry, the y values are repeating themselves. And the minimum value is at the coordinate -2, -10, which is the vertex or the minimum of this parabola. So this table basically confirms what we were talking about when we were using the graph. So as I mentioned in the beginning of this video, the a, b, and c values can tell us properties about the quadratic function. So as you know, the graph of a quadratic is called a parabola. If the a, or the leading coefficient, is greater than 0, then the parabola is going to open upward. If a is less than 0, aka a negative number, then the parabola will open downward. Here's the new piece of information that we haven't talked about yet. The axis of symmetry is the line x equals -b over 2a. So once you're given a quadratic, you need to identify what the a, b, and c values are that are given. And then basically you just take the a and b value and plug them in for this equation, x equals -b over 2a, and you'll get the equation of the axis of symmetry. And remember, the axis of symmetry, the x-coordinate of that vertex is the axis of symmetry. So we basically just take that value and we have half of the vertex coordinate once we find out the axis of symmetry. The way that you figure out the y-coordinate of the vertex is you just take whatever number you get for the axis of symmetry and plug it in for the equation, the original quadratic equation. The other piece of information that we want to identify is the y-intercept of the parabola, and that is the coordinate 0, c. So remember, you find the y-intercept by plugging in 0 for x, so the only value that's left once you plug in 0 for x is the c value, so that would be the y-intercept of the parabola. And then you can see right here we just have two general drawings of the parabolas, one opening upward and one opening downward. If you are curious as to how we came about this equation, x equals -b over 2a, on page 203 of your textbook, there is basically a proof or a way to get that equation. In this example, we're going to be graphing a quadratic function, specifically the one y equals x squared plus 2x plus 3. And just to remind you that this concept of quadratics, we have touched on this in Algebra 1 and Chapter 9. So hopefully this is coming back to you as we go through this lesson together. So first step you want to do is identify your a, b, and c values. So I typically write the a, b, c right below each one. And remember, the a and the b values are just the coefficients of the x squared and the x, and the c value is just the constant or the y-intercept at the end. So we know that a is equal to 1, b is equal to 2, and c is equal to 3. Now we want to use these values to come up with the equation of the axis of symmetry and draw that on the graph. So using the equation that we just talked about, x equals -b over 2a, I substituted in 2 for b and 1 for a, and I'm going to get the equation x equals -1. So the axis of symmetry is at x equals -1. So now we can go to the -1 on the x-axis and draw a dashed vertical line through that point. Remember, the axis of symmetry is where the parabola can be mirrored or reflected to get the exact same thing on the other side. And we're drawing it as a dashed line because it is not actually part of the parabola itself, it's just to help us reflect in the end. Now what we want to do is find the coordinate of the vertex. We know that the x-coordinate of the vertex is -1 because, as I mentioned earlier, whatever number you get for the axis of symmetry, that is the x-coordinate of the vertex because the vertex is on that vertical dashed line. So we know the x-coordinate is -1. The way that you figure out the y-coordinate is you plug in -1, or whatever the x-coordinate is of the vertex, in for the original equation. So we're going to have y equals -1 squared, make sure you use parentheses, plus 2 times -1 plus 3. And when we simplify that, we get 1 minus 2 plus 3, and that equals -1 plus 3, and that's 2. So that means the coordinate of the vertex is -1, 2. So now let's plot that on our axis of symmetry. Now that we have our vertex plotted, we want to come up with a few more points that are on this parabola. And as I discussed earlier, the c value is the y-intercept. So that means our y-intercept is 0, 3. So I'm going to plot that. And as we talked about before, the reflection across is another point. So you see how this is 1 unit away. The y-intercept is 1 unit away horizontally from the axis of symmetry. So you can count 1 unit on the other side. And that coordinate is -2, 3. So we have a few points on the parabola. Now we just want to plot those points and draw a smooth curve through these points. If you wanted to get more coordinates for this parabola, you could always make a table that we have done in the previous lesson video. And remember, a is greater than 0, which confirms that the graph is opening upward. So this completes the process of graphing a quadratic function in standard form. So now we've touched upon vertex form and standard form of quadratics. In this example, we're going to learn how to go from standard form to vertex form, and they are related to each other. So the first thing we want to do is identify what our a and b values are. And just to remind you, the form that we're about to transform into is the equation y equals a times the quantity of x minus h squared plus k. So at the moment we just have the values for a, b, and c. Now we need to come up with the values for h and k. We already know the a value, and that's 2. So vertex form, the name of the form tells us that we must know the vertex in order to get into that form. So we're going to be using the same equation that we talked about earlier in this lesson video, x equals -b over 2a. And I'm going to substitute in the values of b and a. So we have -10 on top and 2 times 2 on bottom. That is going to reduce to -2.5 when you divide. So that's going to be the x-coordinate of the vertex. That's also the axis of symmetry. And then hopefully you recall from earlier that the way that you find the y-coordinate of the vertex is you just plug the x-coordinate in for the equation. So y equals 2 times -2.5 squared plus 10 times -2.5 plus 7. And make sure you're using parentheses, especially when you have negatives involved. So when you multiply all that out, you should get y equals -5.5. So that means our vertex coordinate is -2.5, comma, -5.5. And I want to label right below that HK. So now let's rewrite our general form of the vertex form. So y equals a times x minus h squared plus k. So the a value, we're using the same a value as above, so that's 2. So y equals 2, open up parentheses, x minus -2.5 squared. And then for the k, it's -5.5 or -5.5. And you can see right there we have a double negative going on, so of course we want to take care of that by making it a positive or a plus sign. So that means our vertex form is y equals 2 times the quantity of x plus 2.5 squared minus 5.5. Our last example of this lesson is a real-life application problem. So let's read this together. The New River Gorge Bridge in West Virginia is the world's largest steel single arch bridge. You can model the arch with the function y equals -0.000498 x squared plus 0.847 x, where x and y are in feet. How high above the river is the arch? How high or how long is the section of the bridge above the arch? So you can see right here, we have the distance between the base of the arch and the ground, which is 516 feet. That will help us figure out how high above the river is the arch. The length of the bridge above the arch is this distance right here that we'll be finding as well. So you probably have guessed that we're going to be using the calculator for this because we have some crazy decimal numbers. So you want to go to y equals, and you can clear the previous equation that we were working with. And then take a moment to type in your equation. And right now it's just giving us our standard zoom. So as you know, we're only dealing with positive numbers, so we can go to our window and change the minimums to zeros for x and y. And then for the maxes, I'm going to make the x max 2000 and the y max 500. So now we can see a nice curve that reminds us of this arch bridge. So to find the vertex coordinate, we want to use our equation x equals negative b over 2a. So I labeled our a and b values in the given quadratic equation, and then I'm using this equation. I plugged in the b and the a respectively, and I'm getting an approximate x value of 850. To find the y coordinate of the vertex, you just take the x coordinate and plug it in for the given function. When I did this, I got an approximate y value of 360. So that means our vertex coordinate is about 850, 360, and we'll typically have to round in real-world situations because the numbers aren't always perfect. To confirm that we got the right vertex coordinate, I'm going to use the same process as I used in a previous example in today's lesson. So let's go to Second Calc, and this time, the last problem we did a minimum problem. Hopefully you're realizing that this is a maximum problem because the parabola is opening down and the leading coefficient is a negative. So let's go to maximum, press enter, and then go to the left side of the curve, press enter, and the right side, enter, and one more time enter, and we get a coordinate of approximately 852, 360 or 361, so we're pretty close. Coordinate of the vertex, we can find the height of the arch above its supports, and the y coordinate was approximately 360, so that means the height is about 360 feet above its supports. Now we're going to use this number 360 as well as the given distance between the base of the arch and the ground to determine the height of the arch above the river. So now that we know that the height of the arch is 360 feet approximately, and the distance between the base of the arch and the ground is 516 feet, you probably have guessed that we just need to add those two values to get the total distance. So I did that, and I found out that the arch is approximately 876 feet above the river. Last thing we need to do is find the length of the bridge above the arch. The x-coordinate of the vertex is half the length of the bridge above the arch. So remember, the x-coordinate of the vertex was 850 approximately. So if we know that the vertex is halfway between the first point and the last point, aka the x-intercepts essentially, then we can just double that x-coordinate or add it to itself. So that means the length of that part of the bridge is about 850 feet plus 850 feet, which is equal to 1,700 feet long. Here's our lesson check problems for section 4.2. Take a moment to write them down 1 through 5 and make sure you answer them fully, show your work, and then let me know if you have questions the next time we see each other.